Welcome to the DIY Honda Garage channel. DTC P0171 is a diagnostic trouble code that indicates a fuel system too lean condition in the Honda CR-V 2023 and newer models. When this code is triggered, it means that the engine control unit, also known as the powertrain control module, PCM, has detected a problem where the air-fuel mixture is not adequate for combustion. This often results in long-term fuel trim, LTFT, values being higher than acceptable limits. The PCM uses various sensors and parameters to determine the appropriate air-fuel mixture. If it becomes too lean, serious engine performance issues may arise. It is crucial not to clear this DTC before troubleshooting, as it could erase valuable diagnostic information that may be needed to pinpoint the root cause of the problem. In order to effectively diagnose this issue, you will need to inspect various components, including the mass airflow (MAF) sensor, intake air system, and others as outlined in the manual. The P0171 code indicates that the fuel system is too lean, meaning there is too much air in the air-fuel mixture relative to the amount of fuel. Key components involved in this diagnostic trouble code include the mass airflow (MAF) sensor, which measures the amount of air entering the engine, the intake air system responsible for delivering air to the engine, and the engine's fuel delivery components. Moreover, it is important to check systems like the positive crankcase ventilation (PCV), fuel injectors, and the air-fuel sensor. The MAF sensor, generally located between the air cleaner and the intake manifold, plays a pivotal role in informing the PCM about the amount of air, which is crucial for maintaining the correct air-fuel ratio. Any malfunction or leakage in these components may result in the stored DTC being triggered, leading to potential driving issues and increased emissions. There are several potential causes for the P0171 code, which include failure or malfunction of the mass airflow (MAF) sensor. If the MAF sensor is damaged or dirty, it may provide incorrect readings to the PCM, leading to a lean fuel condition. Additionally, leaking in the intake air system can introduce excess air, also contributing to a lean condition. Other possible issues include inadequate fuel pressure due to clogged fuel filters or failing fuel pumps, which could prevent the correct amount of fuel from reaching the injectors. Leaks in the positive crankcase ventilation (PCV) system and problems with the air-fuel (AF) sensor can also cause or exacerbate the lean condition. Each of these components must be inspected thoroughly to isolate and correct the underlying issue leading to the DTC being set. The symptoms associated with DTC P0171 can vary in severity, but generally include poor acceleration and overall sluggishness. This is because a lean fuel mixture can prevent the engine from producing adequate power. Drivers may also notice that the check engine light has illuminated as a warning. Furthermore, the vehicle may experience rough idling, where the engine may feel unstable or vibrate unusually while at a standstill. Increased emissions could also be a consequence of the engine running inefficiently, which could lead to failing environmental regulations. In extreme cases, particularly during heavy acceleration, the engine could stall due to insufficient fuel being available for combustion. Drivers experiencing these symptoms should consider seeking professional diagnostic assistance. The first step in troubleshooting DTC P0171 begins with starting the engine and allowing it to idle without any load, ensuring the vehicle is in either park, P, or neutral N mode. The Honda Diagnostic System, or HDS, should be utilized to monitor the data stream for the AFFB air-fuel feedback short-term fuel trim value. If this value exceeds 1.33, it confirms that the failure has been duplicated, indicating a persistent lean condition within the fuel system. Ensuring that the engine is at the correct idle state is crucial, as any additional load may skew the readings you are looking for. Successfully completing this step lays the groundwork for more detailed diagnostics of the associated systems. In the second troubleshooting step, you will review the HDS onboard snapshot and prioritize recording the AFFB air-fuel feedback value from when the DTC P0171 was first detected. Following this data retrieval, a controlled test drive should be performed under the same conditions that led to the DTC being set. Factors to maintain consistency include engine speed, vehicle speed, and sensor readings such as the relative throttle position, RELTP, and accelerator pedal position, APP sensors. Achieving similar driving conditions is essential for ensuring accurate comparison and validation of the fuel trim readings. If, during this test drive, the AFFB value exceeds the threshold of 1.33 again, it confirms that the lean condition still persists, allowing you to move forward in diagnosing the root cause of the issue. The third troubleshooting step requires a close inspection of the mass airflow MAF sensor and intake air temperature IAT sensor, both of which are crucial in measuring the amount of air entering the engine. First, visually inspect the MAF IAT sensor for any visible obstructions, such as dirt, lint, or other foreign objects that could impact its function. The integrity of the sensor directly affects how the engine control unit calculates the air-fuel mixture. Ensure that the sensor connections are secure, as loose connections could also trigger erroneous sensor readings. If the sensor appears clean and connected properly, a functional diagnosis using the HDS tool should be conducted to confirm that it is operating within the specified parameters. Failing to accurately assess this component may lead to misdiagnosis of a lean condition, wasting both time and resources. Moving to the fourth troubleshooting step, it's important to conduct a comprehensive inspection of the intake air system for potential leakage. Begin this process by examining all components situated between the air cleaner housing and the intake manifold, as this area is critical for delivering air to the engine. Common leakage points might include poorly connected hoses, deformed or damaged parts, or faulty gaskets. Any leaks in this area would allow excess air to bypass the MAF sensor, therefore affecting the air-fuel mixture and triggering the DTC. Confirming that there are no leaks in this system is essential. Ensure that all components are secure and in good condition. Documenting any irregularities found during this inspection will assist in properly addressing the P0171 code. The fifth troubleshooting step focuses on checking the positive crankcase ventilation (PCV) system for potential leaks. The PCV system plays a vital role in managing engine crankcase pressure and recirculating gases back into the intake manifold. Inspect all connections and hoses associated with the PCV system, as poor connections may lead to undesired air intake that could contribute to a lean condition. Look for signs of wear, damage, or deformation in these parts that could result in leaks. Confirming that all components of the PCV system are intact and operating as intended is crucial to eliminate this system as a cause of the DTC. If any issues are identified during this step, they must be rectified to prevent them from affecting the performance of the vehicle. In the sixth troubleshooting step, you will inspect the second PCV system for leaks and performance issues. Similar to the first PCV system, review all components, including the PCV valve, hose connections, oil filler cap, and dipstick for possible leakage points. Each of these components must be verified to ensure that they are properly secured and free from damage. Detecting any abnormalities in this system will allow you to address them immediately, thereby reducing the chances of additional air intrusion, leading to a lean condition. This step is vital because a malfunctioning PCV system can also lead to poor engine performance and trigger DTCs. Completing this inspection effectively can strengthen your diagnosis and streamline the repair process. Step 7 of the troubleshooting process requires inspecting the evaporative emissions control (EVAP) purge system for any potential leaks that could be contributing to the P0171 code. This system is crucial for capturing and rerouting fuel vapors from the gas tank back into the engine for combustion. As such, a failure in this system can significantly influence the air-fuel ratio. Carefully check all components associated with the EVAP purge system for signs of wear, damage, or disconnection, as any leaks here could allow extra air into the intake. Just like with prior inspections, confirming that there are no leaks present is essential for isolating potential causes of the lean condition. A thorough inspection of the EVAP system could either rule it out completely or identify necessary repairs that can alleviate the P0171 issue. During the 8th troubleshooting step, focus on inspecting the turbocharger (TC) bypass system for potential leaks. The TC bypass system plays a critical role in managing the air intake in turbocharged vehicles. Any leakage in this system can disrupt air delivery to the engine, thus affecting the overall air-fuel mixture. Checking all connections, hoses, and components in the TC bypass system for signs of wear or damage is essential. If there is any indication of leaking, it must be addressed immediately, as it could be the source of the DTC P0171 being triggered. Ensuring that this system is intact and functioning correctly helps to solidify your understanding of the vehicle's performance metrics and can guide you toward effective solutions. Step 9 involves conducting a high-pressure inspection of the fuel system, necessitating the engine to start and to be held at 3,000 RPM without load until the radiator fan engages, after which it should return to idle. Utilizing the HDS, perform the DI, direct injection fuel pressure test during this operation to confirm that fuel pressure levels are within normal specifications. Normal conditions should yield a reading that fits into a predetermined range specified in the service manual. If the pressure test results are abnormal, indicating levels outside the expected range, it suggests that further diagnostics are needed, specifically looking into DTCs P0087 or P0088, which pertain to fuel pressure issues. Confirming that fuel pressure operates within normal parameters is crucial for isolating the cause of the P0171 code. The following step involves inspecting the quality of the fuel being used in the vehicle, as poor fuel can also lead to DTC P0171. Start by draining the existing fuel in the tank, and then refill it with a known good fuel source, which helps to eliminate fuel quality as a variable in the lean condition. Once the refuel is complete, attempt to replicate the symptoms associated with the DTC by performing similar driving conditions that initially triggered the error code. Observing the vehicle's behavior following this replacement will help verify whether fuel quality was indeed the underlying cause. If the symptoms associated with the DTC go away after changing the fuel, it indicates that the previously used fuel may have been a problem, thus validating this step in your troubleshooting process. In this step, focus on the air-fuel sensor, Sensor 1, as potential faulty equipment directly influencing the P0171 DTC. Since there is no direct method to test the A-fuel sensor, the troubleshooting process involves installing a known good component in its place. Once this replacement is completed, repeat the necessary vehicle operation to see if the original DTC will reappear. Observing whether the code remains present or disappears after replacing the sensor is critical for determining its health. If the symptoms persist despite the change, it may suggest the issue lies within other components. However, if the P0171 code does resolve, it confirms that the previously faulty A fuel sensor was the cause of the DTC. Next, you will focus on the fuel injectors, as they are critical for delivering the correct amount of fuel into the combustion chamber. This step also utilizes a known good part, where a healthy injector is temporarily installed in place of the suspected faulty unit. Following this installation, attempt to replicate the conditions that originally led to the P0171 code being triggered. Pay close attention to how the engine responds. If the symptoms dictate oncoming failure, further investigation may be required. If the DTC is resolved after replacing the injector, it indicates that the previous injector was malfunctioning and causing the lean condition. However, be vigilant and ensure to check all related components to rule out any other issues. The final troubleshooting step requires a thorough inspection of the powertrain control module, PCM. If all previous components and systems inspected have been cleared without issue, it is reasonable to consider the PCM itself may be at fault. The PCM is responsible for interpreting sensor information and making adjustments to the air-fuel mixture. Any faults in its operation could lead to erroneous codes, such as P0171. Carry out a detailed inspection of the PCM connections to ensure they are secure and in good condition. After confirming that there are no other abnormalities, document any issues to be addressed further. If the PCM is ultimately found defective, replacement may be necessary to resolve the P0171 code and other associated performance issues. To conclude the troubleshooting process, you must perform a final verification to ensure that the repairs made have effectively resolved the P0171 DTC. This should be accomplished through a recheck using the Honda Diagnostic System, HDS. Monitor for any reappearance of the DTC, as the key goal is to confirm that the repairs successfully addressed the underlying issues identified during the previous steps. If no DTCs are present following the check, proceed to clear the error code from the system. This step not only helps confirm the issue's resolution, but also prevents confusion in future diagnostics. Adequate documentation of the initial DTC, repairs performed, and final outcomes should be maintained for future reference. Proactive preventive maintenance can greatly reduce the likelihood of encountering DTC P0171 and enhance the longevity of your Honda CR-V. It is advisable to routinely inspect essential sensors like the mass airflow MAF and air fuel sensors for any signs of wear or dirt buildup. Keeping the intake air system and all associated hoses in optimum condition ensures that air delivery remains uninterrupted and efficient. Additionally, consistent maintenance of fuel quality is paramount, as using high-quality fuel reduces the risk of contaminants that could affect engine performance. Scheduling regular service checks for the entire fuel system, along with specific attention to the PCV and EVAP systems, can prevent potential performance issues, allowing for reliable vehicle operation. In summary, understanding the implications of DTC P0171 is crucial for effective vehicle maintenance and repair. This diagnostic code indicates a critical malfunction that necessitates identifying the affected components, including the MAF sensor, fuel delivery systems, and the PCM, among others. Following a thorough and systematic troubleshooting process, beginning with initial tests for air-fuel ratios and progressing through to component inspections, can help isolate and resolve the issue. Each diagnostic step is designed to logically eliminate potential causes, ensuring that the ultimate solution targets the exact source of the problem. By adhering to these structured troubleshooting protocols and employing effective preventive maintenance, vehicle owners can navigate and mitigate any challenges concerning air-fuel mixture issues efficiently. Please like and subscribe to the channel. See you next time.